Have you ever wondered, why can't we see further into the universe than 13.8 billion years? Why does everything seem to begin at the cosmic microwave background, the faint glow left from the birth of the universe? And perhaps the greatest question of all, what came before the Big Bang? Did the universe emerge from nothing? Was there an era before time itself? Could there have been another universe before ours? Or is our Big Bang just one among an infinite chain of cosmic events? Today, we will go deeper than most people ever do, exploring the real scientific theories at the edge of cosmology theories that try to explain the origin of everything, the true age of the universe, and the nature of existence itself. This is a journey back in time, past the oldest light we can see, past the first atoms, past the first particles, all the way to the very beginning and beyond. The observable universe is not the whole universe. Let's begin with an important idea. The universe is not 13.8 billion light-years wide. It is much larger, at least 93 billion light-years in diameter, and possibly infinite. So why do we only see 13.8 billion years of history? Because light has a speed limit, the cosmic speed limit. Light has been traveling toward us since the beginning of time, but the universe has been expanding faster than light can cover the distance. This means the most distant regions are too far for light to ever reach us. The universe expands while the light travels. What we see is only a cosmic bubble of visibility. This bubble is called the observable universe, not the entire universe. So already, we face a limit. We cannot see beyond what light had time to reach us. Why 13.8 billion years is the hard limit of light? Why exactly 13.8 billion years? Why not 20 billion? Why not 100 billion? Because that is the age of the universe, according to our best measurements. The oldest light we can detect is the cosmic microwave background radiation, CMB, the afterglow of the Big Bang. This light was released when the universe was only 380,000 years old. Before that time, the universe was a hot, opaque soup of electrons and protons, and light could not travel freely. We cannot see before 380,000 years after the Big Bang because the universe was opaque. So our vision is not limited by telescopes. It is limited by the physics of the universe itself. To see beyond the CMB, we would need a type of radiation that can pass through that early plasma. For example, gravitation waves, cosmic neutrinos are extremely hard to detect. The Big Bang was not an explosion in space. The major misunderstanding is that the Big Bang was an explosion. It wasn't. The Big Bang was the rapid expansion of space itself. Space didn't expand into something. Space itself appeared and stretched. Inside that newborn space, no atoms existed, no light could travel, no time existed. As we understand it, everything, all matter, energy, and even the laws of physics were compressed into an unimaginably hot, dense state. The Big Bang is not the beginning of matter. It is the beginning of space-time. This is why asking what happened before the Big Bang is complicated. It's like asking, what's north of the North Pole? There is no north of north. There may be no before time. But the truth is more interesting. What happened before the Big Bang? Scientific theories. This is where things get truly fascinating. Modern cosmology does not say that the Big Bang was necessarily the beginning of everything. It simply marks the beginning of the physics we can currently measure. But several theories attempt to go beyond this boundary. Let's explore them. Theory 1. The Big Bang cyclic universe. According to this view, universes expand, then slow down, then collapse in on themselves, and then bounce into a new expansion. This idea solves many problems. No need for creation from nothing. The universe could be infinitely old. Each cycle wipes out the previous one, but keeps certain quantum information in this vision. Our universe may be just one of infinite cycles, like a heartbeat of cosmic creation. But this theory has challenges, mainly related to entropy. Still, it remains one of the most elegant solutions. Theory 2. The eternal inflation multiverse. This is currently one of the most widely supported advanced theories. What it says: once inflation starts the rapid expansion of space, it never fully stops. Inflation ends in certain regions, creating bubbles. Each bubble becomes a universe with its own physics. Our universe is one such bubble. Inside it, inflation ended 13.8 billion years ago. But outside, the greater multiverse is still inflating. This means Big Bangs happen constantly. There are countless universes. The multiverse may be infinitely old. We can only see our bubble. Anything outside is causally disconnected from us. Theory 3. The quantum creation model. This idea comes from quantum field theory. The idea: the universe began as a quantum fluctuation in a timeless sea of quantum energy. In the quantum world, particles can appear from nothing, exist for a moment and disappear again. If the universe began as such a fluctuation, then the universe didn't come from nothing, it came from the quantum vacuum. Time itself emerged with the fluctuation in this model. Asking what happened before is meaningless because time is part of the universe, not something outside it. Theory for a universe before our. Some models of string theory suggest that branes multidimensional surfaces collide. Each collision creates a Big Bang. Our universe is the result of one such collision. This implies there may have been a universe before ours. The Big Bang was not the beginning, it was a transformation, not a creation. So why can't we see before the Big Bang? Even if something existed before the Big Bang, we cannot see it because 1. Time and space began with the Big Bang in standard theory. If time didn't exist, there is no before. 2. Light cannot pass through the primordial plasma. Universe was opaque. 3. Inflation erased previous information. Inflation stretches space so quickly that any earlier structures were smoothed out. 4. Even gravitation waves may not survive the bounce or inflation if the universe cycles. Each new cycle resets the observable information. This is why we are fundamentally limited in how far back we can see. What we can detect beyond light, even though we cannot see further with light. We have 2 promising tools. 1. Primordial gravitation waves. These could give us information from the earliest fraction of a second or even before inflation. Detecting them would be like hearing the universe before it became transparent, like hearing vibrations through a wall. 2. The cosmic neutrino background. His neutrinos originated when the universe was just 1 second old. They would give us a snapshot far earlier than the CMB. We haven't detected them yet, but future technology might unlock them. Could another Big Bang happen? Yes. In most advanced cosmological models, another Big Bang is not only possible, it may be inevitable. Depending on the theory, the universe may go through infinite cycles. Inflation may create universes endlessly. Quantum fluctuations may spawn new universes spontaneously. Branes may collide again, so the Big Bang might not be a unique event. It might be one of many, perhaps happening all the time across a vast multiverse. Conclusion. The mystery of our origins. We live in a universe that is expanding, filled with galaxies born in a hot, dense beginning, limited by the reach of light, governed by laws we barely understand, and possibly part of something much larger. We can see back to 13.8 billion years because that is when the universe became transparent. Before that, the universe hides its secrets behind a cosmic veil. But we are getting closer. With new telescopes, new detectors, and new breakthroughs in physics, we may one day see beyond the CMB, beyond the beginning, and perhaps glimpse what gave birth to our universe in the first place. Whether it was a quantum fluctuation, a cosmic cycle, a brane collision, or a multiverse of infinite Big Bangs, one thing is certain: the story of the universe is far from over, and we've only just begun to uncover its first chapters. Follow for more cosmic discoveries, and check out my guides in the bio.